there are certain other steps which are involved in the whole casting process, and we will revise them again. So first of all, what you do, you make a mold which is made up of sand, clay, and binder, and simultaneously in the same foundry you melt your metal in the melting furnaces. And then this mold, you can say mold preparation, it involves the pattern making, cone making, and the gating systems. So gating system is basically a network, or you can say the system of basically different entry positions into the mold cavity, through which your metal is poured satisfactorily into the die cavity. So there is a particular design process to make appropriate gating system, and again gating system also includes the designing of your riser. So riser, I told you that it should be designed in such a way that it should provide enough amount of metal during the solidification stage in order to compensate the solidification shrinkages. And so you have the molten metal in your hand, and then you have already prepared your mold cavity. Now the second step is to pour your molten metal into the mold cavity, and then you allow it to solidify. So solidification takes place, and in the welding technology, I have already covered the solidification of the casting. You know that how the solidification takes place. So for a solidification to occur, what you require constitutional supercooling, and then it will lead to the formation of nucleation of small grains, and those grains are they are grown over some surfaces. So if they are grown over some surfaces, then it becomes the heterogeneous nucleation. Otherwise, by lowering the energy of the molten metal, you can also facilitate the homogeneous nucleation in the casting, and then solidification takes place and formation of microstructure takes place. The next step is to take out the casting from by breaking your mold cavity, by breaking the mold. So it involves the jolting and shaking of the mold cavity in order to remove the riser and the gating system, and also to remove the cast product. And then after that, it will involve the trimming and cutting of your solidified part. And you all know that the casting may also involve the setting of residual stresses into the material. So those residual stresses must be relieved. So sometimes some heat treatment is followed, and that heat treatment will particularly will be annealing or normalizing, so that it will restore the ductility of your cast product. And restoration of ductility is also a very important you can say the aspect, because you all know that casting is can be full of defects. So if more number of defects are present, so they will promote the brittle fracture. So only the ductility or the proper amount of fracture toughness or the toughness can take care of this brittleness in the cast product. So you require the proper heat treatment method, and sometime in order to improve the hardness and the strength, some mud tempering is also performed. And sometimes you can reduce the amount of residual stresses with the help of short peening or grit blasting. So that grit blasting involves the bombardment of small grits made up of sand particles, or it may be made up of small steel balls that are bombarded at predefined flow rates on a particular section of the casting. So it performs two functions. First of all, this short peening, it imparts the compressive residual stresses on the surface, and you all know that the surface is the primary location for any any failure to initiate. So there the compressive stress will nullify the residual stresses, and then it will also reduce the chances of any catastrophic failure arise from the fatigue or any impact. So after this short peening is performed, sometimes your casting is full of very dull appearance due to the formation of oxide scales. So in most of the cases, this grid blasting and short peening, it can also remove the oxide scales formed on the cast product surface, and then the leftover material is removed in the cleaning and finishing of this stage, so which involves the cleaning of cast product with the help of detergents or some chemicals, which can easily remove the dust or any moisture or any oil oil impurity from the cast surface. And you should select this cleaning agents in such way that it should not corrode your solidified product or your casting. And then in the last stage you perform the inspection. So inspection can be done with the help of visual inspection, and we have already studied about various types of non-destructive testings. So those non-destructive testings can also be utilized in the inspection of the casting. So we have learned ultrasonic inspection. We have also learned about the radiographic inspection, magnetic particle inspection, dye penetration. So you all know that casting will have different similar types of defects which are present in the welding, such as the porosity or cracks, formation of cracks, or any discontinuity in the material. So non-destructive testings are performed, and sometime if you really want to estimate the performance or the strength of the product, then you take out a standard sample from the material of your cast product, and then you can perform the destructive testing in order to quantify or measure the different type of strength and toughness of the material. And then if the casting is full of defects, then you have to rethink about the process which you have adopted earlier, just like that what is the reason behind of such defects. Like it may be due to the presence of more amount of moisture contained in the this sand mold, and that if you are not taking care of proper shielding of the casting process, and if there is some error while pouring, and if your riser or this runner is not properly designed, and if your mold cavity is not of sufficient strength, so different types of defects like you can say blowholes and porosity can also arise. So such defects can be estimated and in the inspection stage. And nowadays with the advancement of the technology, there are different types of simulation softwares available in the industry that allows you to simulate the whole casting process using with the help of finite element method analysis, FEM analysis. So there are different softwares like Flow 3D is one of these software in which you can perform this solidification or the casting process, and it will give you a prediction about that which areas are need to be correct or to be modified in order to reduce the casting defects. So in the simulation, it will show you that how the material is filling inside the mold cavity, and what is the temperature distribution in the whole casting material, and how the solidification is taking place. So you can visualize and you can have a prediction about the different casting product and the quality of the product after the solidification or the casting process is completed. So if you have any interest, then you can go through that particular software that is called the Flow 3D. And I also know some different specialized softwares. So if you have any if you have any interest in doing the simulation of casting process, so you can drop a mail to me. I will send a link of those software. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.